Hi Fran, Dick out here in Scottsdale, Arizona. Um, what we're seeing here is about 4 minutes of shuttle video. This was released as a, uh, you know, highlights of the day thing. This was not aired live during the day. This gentleman who supplied this footage records everything that comes down NASA Select. And so the question is, why were we allowed to see something like this? What I did then, my copy, let's see, which is an SVHS copy, so mine would be a second generation copy, then placed into, I recorded as SVHS into my computer. I'm using a macro, it's MIRO DC-30 capturing system. This is a system that allows you to capture at 60 fields per second or 30 frames per second. There's 2 fields per frame at full resolution, at full grayscales, and thus. But prior to putting it in there, I ran it through my analog processor. So actually, the version I ship you looks better than my source's video, and one of the things you notice right now is lightning storms. We believe that this was taken over the Atlantic Ocean on the west coast of Africa, looking toward the west. What I've done here, we're running just the video as it was, and then I will run it by hand, and allows you to kind of do a fast play, fast forward, things like that. Then I'll do a stepping of the first object as it comes into view, and then a stepping as the one comes out of the clouds, and I'll go back in there. So I'll comment on that. The video AVI file for this is 542 megabyte in size for approximately 5 minutes. With a 3.8 gig hard drive, it'll allow me to record about 35 minutes of live video at SVHS quality, which is pretty much better than most people see it coming over on a TV. The camera now is simply rotating, and they're going to concentrate on these 3 objects down here in the right hand portion of the screen. I don't know why it has this fuzz out. We've seen this on a lot of their videos, but there again, this was the disc that was the first one you saw. It came off, it stayed intact, but I'll try to describe things, and then you can replay the video and see that. Now you see this blinking one going up the left side of the screen. Now nothing moved on that, by the way. That thing that moved to the right there is simply because they pulled their zoom back in. It appeared that the objects were moving, but it wasn't. You can see the air glow layer. No, I can't do that. I was going to say, there are portions of this tape that I didn't give you, but all that is prior to this, and you can simply see how the normal sky looks and that, so it's just a reference. But there's 4 minutes or plus of action on this thing here. And you can still see that one object receding in the background, and you can see also the lightning still occurring. That is one common thread between the STS-80 footage and the STS-80, but we now have, okay, now we're going to restart the sequence here, and I'm actually just moving a slider on the software, and I can go back and forth here and run it in fast forward and fast rewind. I'm looking for a AVI player that will allow me to do like double time and quadruple time in real, so I don't have to render it. I can do it rendering, but it takes all night to render through Adobe Premiere and that. Now you start to see this object, and this object, obviously something is rotating it, though you got to remember television pictures don't always tell the truth exactly what's happening, but we can be sure that it is rotating. And it's at a subdued brightness coming in from the bottom right hand corner. There's lightning going ahead. You can see that. I'm just hand stepping this, clicking on a mouse about once every half a second is what we're doing. You're going to see one coming in now from the top left-hand corner, and notice it has a tail on it because it has such a fast speed right now. But you're going to notice it's going to slow down, and as it slows down, of course, the tail disappears on the object on the top left corner. At some point here, this object that now is at the bottom center has now gone to full luminance, and now they're going to be moving together, the one coming from the top left and the one entered from the bottom right. But both objects slow down like they actually have seen each other, and they don't stop and dock with each other, but they almost come to a standstill for just a moment. Notice there's other objects going through the picture as this is happening. Okay, that's me stopping the tape there. Okay, and now either that object has gone into brighter luminance, but now it is stationary, noticing that it's going now with the rotation of the Earth. And the next object we're going to look at is going to come up through the clouds here, just about at the 12 o'clock thing there, where you see all the twinkling in the center. Again, this is an interesting artifact on these NASA cameras, why they have this center twinkling problem. I don't know. The cameras are set for maximum sensitivity, so when it gets too bright, it actually turns dark in the center. Notice when you see the lightning storms. So actually, that other one, which is toward the bottom of the new big one, could actually be brighter than it was before. I don't think it is, because I think it would be a bigger diameter. So I think it is dropped down a little bit in luminosity. Okay, and we're going to let this thing then just kind of finish the segment, and I'll try to point out some other things. Notice what's going on toward the bottom of the picture, both at the left side, center, and right. And there's a lot of stuff in the background. You rerun this tape over and over again, you're going to see things you missed the other time you watched it. No audio. This was a replay of the highlights of the day. There's no audio to go with it. But we have a lot of references. We have a thing that zooms in. We have an object then that parks itself and rotates with the Earth, and that object, it will now leave and go over and meet the other ones here in just a moment. If you keep an eye on what's going on there, there's one that just goes from the air glow layer into the Earth's atmosphere. And okay, what happened to the other guy there? Disappeared on me. Okay, now the camera again is going to rotate. The flashes could be the adjuster rockets on the shuttle. Just don't know. By the way, this was the mission that they weren't allowed to go out the air hatch. Remember, they couldn't open the air hatch. Now, zooming in again, you can see that this is a similar object. If you can't see it on your screen, you know that little monitor you talked to me about using Commodore, whatever it was. That's what I use. I use a green monitor to look at these in detail. But you know, can either use a TV set or whatever the best monitor you have. And I'm just kind of going back and forth here, just showing, you know, some things to look at. Sometimes in fast motion you see some things that you miss in slow motion. After I do the slides of that one crater, and I did get the crater's name, and I'll have to stop the tape at that point and look up and then get back. What I'm doing here, I'm adding the audio track after I added all the video. I think I let this run now 3 more loops on a repeat basis. This way it's real nice if you're going to have a meeting, one of your MUFON meetings, or a display at some shopping center like we do. You can let this thing run and it repeats itself. Plus you don't wear out your tape by replaying the same segment. So this runs through without any stopping. And again, there's a lot of stuff that's not very brilliant that you'll catch as you watch this thing, but this is really probably the most amazing video we've had. We have objects going in all different directions, which kills the theory of the thruster fire or ice. I mean, obviously, you know, this isn't swamp gas we're looking at. Strange Universe was going to run this segment. Bill Hamilton is the party who I got this footage from, and he got it from the gentleman out of California. And Strange Universe has backed off on this until they said they get NASA's reaction to it, and so far NASA will not reply about this. So we'll just let this thing run. I saw in the news last night your flooding out problem you had. They were showing Cincinnati, so they got hit real hard. And of course, I'm from Cincinnati, and I saw you guys got a lot of water up there. We had some rain too, but it was just our normal. We had about 1 inch to 2 inches, and you know, and then we have to get enough of that plus a snowpack to have our water supply for the rest of the year. Okay, so let me think what else I'm going to talk about. One of the things that I'm noticing in the UFO field now, Fran, is that a lot of credibility is lacking with a lot of people who claim that they're investigators, things of that nature. And I've taken some shots on the internet, bucking some of the footage that's been put up there. I did a real thorough investigation on that Colorado footage, and we found that most probably that is actually light caught in a spider web. Whether the man hoaxed it or not, I can't tell you. I can tell you that every person that I went out and had similar video had talked to Tim Edwards. So they weren't shooting any UFO footage before that, and we can duplicate the Salina, Colorado's footage generally any sunshiny day. I'm wondering how you guys are doing looking at hail bop at your look angle, and also the weather cover, having clouds as a problem. Normally we have nothing but clear skies, and we're going to be doing a sky watch for hail bop probably in I think we're going to do it the first week of March. And we also have a field trip for our group. We're going to go to the large antenna array in New Mexico. It's Socorro, New Mexico. So we're going to take a bus and rent the bus and take it over there for just a one-day trip. I'm pretty well set now doing video editing. I had a lot of problems with the first board they sent me, and I had a difficult time convincing them that the board was defective, and finally just threatened to charge it all back on them. And I sent it in, and finally they sent me an all-new board, and it works just fine. But this is really neat to be able to have high-quality video and be able to edit it on the hard drive. That eliminates, $40,000 to $50,000 in editing decks that you normally would have to try to even come close to the job this does. The downside is, of course, it doesn't do the editing in real time. It's all, what they call, I'm trying to think of the right name. Sorry. It's called rendering, so it takes a lot of time to do rendering. So when I'm doing high quality work, I can let the computer work on it all night and even during the day while I'm out working, so that's not a real big problem. Also, I think after the slides that I'm going to have on the moon and that, I run this 2 or 3 more times for some more, so you can just let this thing run at a demo or something like that. Probably should be able to make decent copies for people off of this. It should master okay for one more generation down. I would say the diameters we're dealing with here are somewhere on the order of 10 to 12 the size that we had on the STS-80, and most of that footage was obtained from Maryland cable, and so you already had cable problems. You had a lot of artifacts to deal with, and so I'm pretty happy with what this looks at. I'll pick up the audio again here. I'm just going to log off, and then I'll pick it up again as we get to the slides. might mention here that it's quite obvious the way they handled the zoom camera that they knew what they were photographing, and it wasn't just something that came in while they let the camera run, that they knew what they were doing. Both on that very first, notice that was a real tight shot when that one object came into view from the right hand bottom corner. I noticed that that object had changed. There was a bulge on the right side, if you'll notice that, and it's getting smaller now, but it's now rotating with the Earth, like in stationary orbit. What I'm using as a computer is I have a Pentium 200, a 3.5 gig hard drive is my first drive, then I have a couple of, okay, you'll see a break in the tape where there's a bunch of snow and that, but just keep going because there's just a break between the two segments. Very inexpensive Cirrus Logic card. It happens to be compatible with this this video capture board. My Diamond Stealth was not compatible with it, so this is a very inexpensive board on the order of $35. And I have pipeline cache on this, and you know the other things, the CD-ROM. What I've done though is for all my video processing, all its power for all my video processors is derived from the computer, and that way I don't have any hum bars drifting up and down in the picture, and that's because everything is gen locked at a high frequency and wouldn't show there. That was one of the keys to trying to make good quality video transfers on a budget. Okay, break in the tape here in just a moment, but just let it be about 2 or 3 seconds of snow. Okay, this is I'm working on this thing. I don't know if you heard about the book that came out that said that the Apollo moon photos are all faked and everything. So I went and pulled some of the same photos out, and some of these, it makes you wonder. This one here, notice that behind the astronaut there on the surface, it's really bright illuminated right there, but in the background, notice how the brightness falls off. Well, that won't happen on the moon's surface because, you know, there's no atmosphere. And then I want you to look as we get closer. That's the camera. That's a Hasselblad that they mounted on the suit. And I want you to look at the reflection in the face here. Notice the one that's taking the pictures. Notice what's happening with the light too. It's almost black, and this leads one to think that maybe these pictures were shot on a sound stage and not actually on the moon. Now we'll get a closer up shot of this here too. I got another one that comes up closer than this. Okay, should be coming up here in just a moment. Okay, and notice we got also the shadows are going 2 directions. Notice the shadow of the astronaut is in one direction. Look at there, we have a shadow going in the other direction. Can't happen. Now these are not the ones out of Fortran magazine. I want to show you here. Notice this is supposed to be Surveyor, okay? And notice there's all kinds of dirt on the landing pod there. Okay, this thing bounced upon landing. Okay, this is a Surveyor, I forgot, Surveyor 3 or whatever that was. And since you would kick up a lot of dust on the descent rocket stage, you would expect that. But look here, it's perfectly, this is the LEM pad, and you've seen them when Armstrong was landing, how much dust was blown up. Look at it, not a speck of dust on this pad here. Again, very suspicious. Now here is something that's very interesting. This is a sequence of 4 photos. And I want you to look at how the illumination changes. Actually, they're in the shadow of the LEM, but notice how nicely illuminated this is. Now, the next picture coming up is him coming down. Notice he should be in the black shadows, but notice the illumination is from the bottom up. Kind of interesting. I'm not saying that we didn't go to the moon, but some of these pictures are obviously not shot on the moon's surface. And then look how bright he's illuminated in this one. Okay, compare that to the moon surface behind him. And then there's one more. And all these pictures I've got out of a NASA publication. Now, the only other explanation that I could see was that maybe these were dodged and burned in. You know, these were slides, so maybe for publications. But look now how dark he is down here. Nothing's consistent, so I would imagine that the astronaut would not have changed exposures from the first shot to the second. I wouldn't think so, you know. And so this is kind of a mystery. Now here again, notice what's odd here. The sun is coming from the top left. Look at the bright spot right to the right of the astronaut. And then look at the bright spot, which normally should be in the shadow of its leg. Look right there, how bright that is. Now the dark area would be because they walked in on that surface. Okay, now again here, what's interesting on this one is on the dish. This is what I saw on the dish. The mesh is fully eliminated, but look at the astronaut. He is in shadow, and that doesn't make much sense either. I got these from several NASA publications out of the library. We have a pretty good source of things here. This is a neat little program. I'm going to pass this one along to you. This is called Thumbs. And I tell you what, you can do more things with this program. You can create catalog sheets of all your graphics. In fact, every picture you see here that I've shown you so far has been pulled up with Thumbs. And you can delete stuff you want. Now here's the LEM, just a picture of the LEM on the surface. Okay, and I'll see here. Now this is what is interesting. This is the one that I'm going to have the better pictures showing you. This is a crater on the far side of the moon, and I'm going to stop the audio right here for a moment and look up what crater that is. Hold on. Well, I'm sorry to say that when I entered in my little portable data book, I must not have pushed the save. I thought I did for sure, but it's not there. But anyway, this is on the far side, and what we're going to be interested in, there's 2 things here. One is the crater itself, and also is that ridge in the background. You see those vertical lines there? Notice there's a whole circle of them. Very interesting. Now we'll get closer and closer here. Okay, looking at this crater, there is a lot of geometric stuff in there, and also all over this side here are lines that travel at 9-degree intersections. This was a like 11 by 17 print. So I scanned this in at 600 by 1200 optical. Now this is what that looks like there, and I took all the lithoplate dots out. Now this program we're using here is the picture publisher I was telling you about, and this is really a fantastic program. And so this is just some of the bottom ones that are big enough that we can do some resolving. Now this is when I only had the 300 dot scanner, but you can still see on this the slope, the evenly spaced spiral slopes there. You can see the digitized area. You can also see the vertical scan lines, but then I'm going to show you the same thing done with a 600 by 1200 dot scanner. Now this has not been interpolated scan, this is actual scan. I went and bought the best one of those. And what I've done here to make it clearer, I've followed with this program and just drew in the spirals for you. And how I did this, since it's a different optical spec on the X and Y things, I scanned it with the book turned 90 degrees, and then I made a composite, so we weren't looking at artifacts introduced by the scanning process. This was another one here. So notice the spacing, and I mean, what would be there on the moon that would cause that? I mean, there's nothing, you know, nothing. And I want to show you some of the things you can do with this program, which is really neat. This I think is my favorite. This is a user-defined filter, so you can set up your own parameters in this. This is very nice. Now Photoshop has this also, but Photoshop does not have the ability to take out dots on a scan. And this is just so much faster to use and does really more functions that we need to do. Now that sky, what was it you had? That one that you mentioned that Dr. Haynes had. I'll try to look into that. I'm going to be giving you another program, actually in the package here. I'm going to give you a program called In Process, which it may be a little hard for you to set up. I don't know. It depends on the mouse you have. It's a DOS program. But I'll tell you what, it does things that no other programs do. And another one I'm going to give you is Fractint, which allows you then to take the moon photos and turn them into fractals. And with that, you can really see a lot of stuff. I used that when I was working on the Hoagland pictures. This is an unsharp mask. It's showing you how sharp that the pictures get with this. Now I'm running with Windows 95, and I'll tell you, it's a real bear of a program, Windows 95. But I'm going to tell you what, this picture program will run approximately 10 times faster in Windows 95 than it runs in. And this is a Windows 3.1.1 program. It's not a Windows 95 version. This is where you can just adjust the contrast, mixes, and you can just see it as it's happening. Now, if I had a better video card than this $40 card in here, when you do zooms, they'd be instantaneous, and I'll be getting a better one sometime down the line. But got to watch the dollars. I have almost now, just in this video capture, about, I don't know, $2,400 invested in software and materials. But that's what I wanted to do. That's the toys that I wanted to have. So I'm going to up the resolution here to, I guess I'm going to do 400 dots per inch. And you can see then with the process we did on that. Now I just did that as a demo. I mean, not much to see doing that. But this is a great little program. It's called Micrographs Picture Publisher version 5.0. The version for Windows 95, they really screwed the program up, and it's not worth buying. But you can see how fast it opens. When I'll show you here, when I open up this thing, it goes past, I mean, boom. And it takes about 4 or 5 seconds to open up in regular Windows. I mean, it's just super fast. And you're in there. And then most of my picture files that I load are on the order of 20 to 40 megabyte in size. And so this is quite a good program. Okay, I think it's time to turn the computer off. Talk to you later.